In this video we will make this octagonal pattern using Revit Adaptive Parametric Modeling. This consists of nested families that have been loaded into each other. The first adaptive type family is loaded into the second adaptive type family, which is loaded into the third family, that is a conceptual mass type. Open an adaptive type template. Place a point anywhere at the ref level and make it adaptive. Set the horizontal plane of this point and place another point over it. Filter out the upper point and assign an offset parameter to it. Assign some value to the offset parameter. Set the horizontal plane of the upper point and place a circle over it. Assign a radius parameter to the radius. Make sure that the radius is an instance parameter. Place 8 points at the circle and select all of them and change the measure from to angle. Place the points at equal distances by assigning values as 0, 45, 90, 135, 180, 225, 270 and 315. Join the points with splines to make an octagon. Do not check the octagon lines as reference line because we want them to be visible in the other file into which it will be loaded. Assign a rotation parameter to the upper point. Open the adaptive type template and place 4 points at the ref level in clockwise or anti-clockwise manner. Make the points adaptive and join with splines to make a rectangle. Check inside the box is reference line to make the lines into reference lines. Place 1 point at the center of each of the lines. Join the points with ref lines. Place a point at any of lines and bring it to the intersection of the lines. Load the first file into the second file. Place the component at the point. Do not forget to check the Always Vertical box in the first family. Hold the component and assign a radius parameter R1 to it. Place more components at the same point and assign different radius parameters to them. R2, R3, and so on. Assign different values to the radii. Set a plane at the line joining the adaptive points 1 and 2 and place a dimension parameter between the points. Create a new parameter. Make this parameter instance and reporting. We are going to use this length to relate to the radii of the octagons. Write R1 is equal to rep divided by a number depending upon how big we want the octagons to be. In the type properties box, right rotation is equal to 22.5 degrees to rotate the octagons. Hold the rectangle formed by reference lines and create a form. Assign a positive offset parameter and a negative offset parameter to it. Assign values to the two parameters. Hold the octagons and write the offset is equal to 0. Hold the biggest octagon and create a void form and assign the same positive offset and a new negative offset parameter. If the void does not cut automatically, then use cut geometry to cut. In the same way, create void forms with the other octagons. The depth of the biggest octagon is going to be the minimum and the depth of the smallest should be the maximum so that they form a step-like pattern. Open a new conceptual mass type template. Place a rectangle at the level 1 and create a form. Hold the front face of the cuboid and divide surface. Change the layout to fixed distance and enter the same value for both U and V grids. Turn on the nodes. Load the second family into this one and place the component in the same direction clockwise or anti-clockwise as we had placed the adaptive points in the first family. Hold the component and press repeat. Select repeater and remove repeater. Go back to the second family, assign a new material parameter to the form and reload the family back into the mass file and overwrite file. Select the component and assign material as needed. Change the graphic display to realistic. To hide the unwanted extra lines, go back to the second file and select the reference lines and the octagons and assign a visibility parameter. Reload and rewrite. Select the component and in the Type Properties box and uncheck the visibility parameter. Please like, share, comment and subscribe.